Hello, my name is Maviv Nair, and I will be talking to you all about our conveyor belt system. Let's first begin with the overview and system design. This system consists of four primary components: the conveyor belt, the floor bar mechanism, the weight scale, and the sensors. As you can see in the image listed below, each of the numbers correspond to each component, and how it operates is the motor drives the floor bar system, which then pushes the object onto a force sensor. The force sensor reads the weight electrical signals and displays a number based on that discrepancy in weight change in electrical signals. The conveyor belt is also driven by a motor, and as the product moves along the conveyor belt, it is stopped using an ultrasonic sensor. The ultrasonic sensor indicates to the motors when to start and when to stop. These are some of our initial design sketches. You can find more details about this in our report. This is also indicated in our report, our initial conceptual design versus our final designs. And moving on, these are our final designs. Here is a video demonstrating how the project works in a CAD assembly. Package moves forward, the package stops in front of the sensors, and then the floor bar is activated to push the package onto the final stage. Here's an exploded view. And these are just the parts that our project is composed of. Moving forward, these are some of our specifications. A full specification list can be seen on our report in the appendix section. These are just general specifications for the motor and the overall system, as well as the force sensor specs. Some challenges that we faced were motor output, system snagging, and sensor motor alignment. Now, what these indicate is, as we put a part on the belt, sometimes the motor wasn't strong enough to push the item, and that was just due to motor power. And we fixed that through calibration and orienting components properly. The system was snagging. What that means is the floor bar system occasionally had friction at the linkages as well as where it was sliding in and out of. And we fixed that through proper alignment and making sure that the linkages were all in sync. Some improvements to fix these issues in the future would be to add spacers to realign these floor bar linkages and use a PWM. Also, using a stepper motor would allow for more efficiency and better output. Some of the assembly overviews, we have a motor to Raspberry Pi Pico. That's what's the computer behind the system, and talking to both the sensors and the ultrasonic sensors as well as the motors. These are all connected to GPIO pins, and the motor runs to move the conveyor belt, like mentioned before, and the crank system, as well as the ultrasonic sensors measure the distance to stop and move the packages, as well as activate or deactivate the conveyor belt and floor bar packages. These are some of the actuators that we used. Again, more of these will be shown in detail in our report, as well as our ultrasonic sensors. Again, more details on this in our report. As for the code overview, going on to the next slide, I will describe some of the code that we used. So we had two main code bases, one for the conveyor belt, one for the floor bar mechanism. Each of these codes are also, again, in detail described in our report as well as in our appendix. But just a quick overview, it goes through each of the pins, the initialization, the activation, and then going through each of the motor values, and then the distances. And then if the proper distances are met, the code will activate, and depending for each code, it's different from the conveyor belt and the floor bar mechanism, and that's all detailed in our report as well. We did use the HC-SR4 EDU shields from our laboratory as a guide and incorporated it into this code as well. Applications and benefits. At the current scale, it is limited to smaller applications in logistics, manufacturing line, and agricultural processing. It can sort packages based on weight. At this current size, it's mainly hardware. Additionally, we can use it to sort agriculture, mainly tomatoes, small fruits, and vegetables. By integrating these systems, it can make manual labor a lot easier, and it'll improve safety by reducing the element of manual lifting. For future design considerations, we are looking to add IoT devices to incorporate a more developed feedback system and allow us to understand where systems are not performing as well as they could, as well as improving our sensors and utilizing more sensors to get precise data. We would love to scale this to a larger scale and use premium materials for better application, as well as smoother applications in our 4-bar system, as well as the conveyor belt system. Another improvement that we would like to add is modularity, so making the system much more feasible for serviceability, which would allow components like the belt to be modified or replaced should it experience wear and tear, because components like the belt would experience more friction and more wear and tear compared to components like the motors. That's it for serviceability. Moving on, we have our final slide, and after this, you will see a demonstration of our project working as a whole. Thank you for listening. That's it.